Good afternoon, everyone. My name is Ben Weisenberger. I'm an application engineer with Allied PLM Solutions. I want to welcome you to the Allied PLM Lunch Byte series. These sessions are designed to briefly explore capabilities within Solid Edge that you may not be aware of. Today's session is part 2 of what's new in ST5. If you have any questions during today's session, please write them down and send us an email. We want these sessions to be informative to you, so please send us any topics that you might have for future Lunch Bytes. Some of the topics I'll go over today. I'll talk about the new rigid relationship. Also talk about barrel cam support. I'll show you some new options when opening large assemblies, and also a new insert assembly copy command. We'll go through some stuff in drafting, some alternate positions draft, auto ballooning, and some improvements with aligning dimensions and annotations, as well as nail boards. So first we're going to start with the rigid relationship. Rigid relationship command has been added to the assembly environment. This works the same as it does in part, where you identify some features or faces to be rigid with respect to each other. Once these components have a rigid relationship, they maintain a fixed position relative to each other during a move. And the best use for this command is when you open an assembly from another CAD system and all the parts come in with no relationships. In this scenario, you can select multiple parts and make them rigid, which saves time from creating relationships between all of them. Components don't have to be active for this relationship to be placed. The relationship cannot be applied to reference plane, coordinate systems, sketches, or assembly feature faces, however. The rigid set relationship works within the family of assemblies and adjustable assemblies the same as any other assembly relationships. And if the rigid set relationship is deleted from Pathfinder on one of the components, it's deleted from all the parts in the rigid set. But if one of the components is deleted, the remaining components will keep the relationship. And I'll show you this in an example in a minute. New capabilities have been added to the existing cam relationship to support barrel cams. The new default selection option is called follower, which defines the geometry that would follow a cam. This relationship only controls the positioning of the follower tangent to the cam, so additional relationships need to be added to get the proper cam motion. And again, I'll show you a couple examples of this and the other relationships you might need to add first. Some supported surface geometry for the follower. As you can see, you can do cylinders, cones, spheres, and then supported chain of curves for the cam. It can be open or closed. It can be a 3D path. And so I'll show you this now in a couple examples. So here's the rigid relationship first. As you can see, we have this roller up here. And let's say we got this from another CAD system. So if we grab one of the components and drag it, you can see they're not connected. If we click on them in Pathfinder, there's no relationships to any of the parts. So what we can do, if we highlight all of them, we can use the rigid setup here and make them rigid. And when we do that, if there were previous relationships, you can choose to suppress, delete, or ignore them between the components of this assembly. We're just going to suppress and hit accept. So now if we click on one of the parts in Pathfinder, you can see now we have the rigid relationship down here. Again, if we click a part and do drag component, it's going to bring all of them along because they're a rigid set now. So then we can use this to assemble it. It makes it easier just to apply one relationship to all of them and keep them as one set. And we can move it and connect it to our part if we want like that. Like I said, if you delete one of the components, let's say we delete the side here, the other parts will still have the rigid relationship. However, though, if we delete the rigid relationship out of the relationships down here, we delete that, it'll delete them from all of the components. So now none of them are rigid anymore. So that's the new rigid relationship. All right, here's an example for the cam follower. What we're going to do, we have to add a couple relationships before we do it. So we're just going to do an axial line real quick between our pin up here. We're going to align it to our coordinate system, the z-axis. And now we can apply our cam relationship, and the default is follower, which is what we want, and we want the end of our pin here to be the follower, so we'll click that. Our next option is face change, so we're going to pick the face of the cam and hit accept. So now if we do drag component and drag this around, you can see that our pin follows the cam. So it's quick and easy to do. I've got a couple more examples of this. Let me close this one. Let's say we have a barrel cam here. We have these two arms that we want to follow our groove. So what we need to do is we want to make these pins our followers, but we need to add a relationship first. So what we're going to do is connect them. So we'll connect our face here, the center point, to our path, that cutout. So now it's connected. Now we need to do our cam relationship. We'll do our follower, and we're going to do an edge chain, and we'll click the edge of this and accept. And now it's in our slot, and we'll do the same thing for the other side. We'll do another connect the center point to our cutout, do our cam relationship, pick our pin as the follower, and then edge chain again the edge of our cutout. Now you can see over here in Pathfinder we have a motor, so we're going to simulate that motor. If we hit play, you can see how the barrel cam spins, and those pins will follow in that groove. So there's some improvements there with the cam relationship. I've got one more example of this. How you can do it with, we did it with a pin here, excuse me. We can also do it with a torus or a cone. These require just a few more relationships to be applied first. So we're first going to do a connect. We'll connect the center point of our torus, and we want to do it to our reference plane. Next we'll make it parallel, the axis of the torus, parallel to our x-axis here. And we'll make it tangent to our cutout. Now you can see it's placed in our cutout there. Now we can apply our cam relationship. We'll select the torus again. We'll do edge chain and select our edge. We can do the same thing with our cone. We can connect the center point. There we go. Now we'll do a parallel relationship between the axis of this and our y-axis. And then we'll connect our center point of the cone to the face and apply a cam relationship to this as well. And we'll do our edge chain again. Hold on a second. Need to make our parallel floating here. Now we can connect that again. Connect it to our face, and now we can apply our cam relationship. So now we have a motor on this one as well. We can simulate this. Let me slow it down a little for you, and you can see both the torus and the cone following it up and down. Alright, so let's go back to the PowerPoint. We're going to talk about large assembly modes and some new options to bring in assemblies. When opening assemblies in ST5, more control has been given to the user to determine how they want to open small assemblies as opposed to large assemblies. The focus of this enhancement is to give the user better control during the opening of assembly depending on how many unique parts reside in that assembly. We have a couple options here, small, medium, and large, or excuse me, yeah, small, medium, large. And under the Open As settings, there's a pull-down list consisting of hide all components. You can change these from yes or no. We have part activation. You can activate all, inactivate all, or do last saved. Part simplification, you can use all designed, use all simplified, or last saved. Sub-assembly simplification is use all design, use all simplified, and last saved. And then active change parts on file open, you can choose automatic or yes or no. And I'll show you what these options do in a minute. Also here, you can now set what equates to a small, medium, or large assembly. So you can change the numbers here from 50, you can make that smaller, and I'll change that in an example to 25. The medium one automatically gets set for you, it's automatically between the small and the large. Alright, another new command is insert assembly copy. It's a new command that takes as input an external assembly file and places it into the top level structure as an assembly feature in the active assembly. The general purpose of this is you can use assemblies. You can also mirror the assembly when you put it in here, and I'll show you more on that in a second. And changes to the source document will update to the assembly copy that you inserted, and I'll show you an example of that. Things to know about the child assembly features: that the parent assembly display configurations aren't available from the child. The same as in patterns, the drag or move component is not available. With the parent, the family of assembly is not supported as a parent assembly, and if a parent is converted to a family of assembly on an update, and then the feature is not updated or warned. Some other things with a new option with it, if you right click on the assembly copy, there's a new feature where you can freeze the assembly so that the feature does not update when you make a change to the original file. And I'll show you an example of that as well. And then you also have the option to mirror it when you create the assembly copy. You can rotate, mirror, or exclude individual parts if you'd like. Same with the insert assembly copy, you can go through and choose to exclude different parts. And I'll do an example of that for you right now. So let's go back over to Solid Edge. Let me open up an assembly here, just a blank one. We'll go into our Solid Edge options, and we have assembly open as, and this is our large assembly options here. So we can go through, we can change these, we can change our small assemblies. Let's say we want to make this 25 unique parts. We can make this a large assembly, let's make it smaller to 500, and if you see the medium, it automatically updates for us. Now what we can do is change our settings for each small, medium, or large assembly. And so what we're going to do is change our medium assembly and say hide all components for medium assemblies. And what we're going to do is hit OK, and we're going to open, I have an assembly we're going to open, and we'll see what that did. So here we have this floor jack, and we have open assembly as auto select. So this will take it from our Solid Edge option setting that I just created. We'll hit open, and you can see there's nothing here. I'll fit it. There's nothing there. They're all hidden. So if we close this and go back to our Solid Edge options, and we change this back to no for hide all components, and we open that assembly again, you can see that nothing's hidden now, and it shows our entire assembly. So what you could do, you could also come in when you go to open, and you can select from here on the right how you want to open that assembly. So from your Solid Edge options, you can choose your small assembly, and so you could make this open as hidden, or you can activate all parts and you save this as your default or if you want. You can also choose what configuration you want to open this as. So there's some new options there. When you're bringing parts in from the parts library, there's another option. If you right click, it's here, assembly, use configurations, and open as settings. If we turn that off for now and we pull in another assembly, you can see it comes in like it always has in previous versions. But if we turn that option on now, we'll right click and turn this on, and we drag in the same assembly, we now get this display here, and we can now choose how we want to open this assembly. We can do the auto select, or we can choose to open it as a small, medium, or large assembly, and what display configuration we want as well. So there's some new options. You can either have this come up every time you bring an assembly, or you can turn it off simply by right clicking over here in your parts library. Alright, the next thing I'm going to show you is the insert assembly copy. So here I just have an assembly, and all it has is a second coordinate system in it. And what we're going to do is we're going to come up here to insert assembly copy, and we're going to insert a new assembly copy here. And we're going to pick our assembly. We want this roller table. So we'll hit open, and when we hit open, it comes up with this dialog box here. And here we have the choice to choose what coordinate system we want. We can choose either base coordinate, or we can choose the one we created, and we're going to go with that one. You can add new components on update, include all assembly features if you want. Then you also have the option to mirror, and you can choose what plane you want it to mirror around, and that is relative to the coordinate system you choose. You can also choose the action. With the mirror, you have the rotate, mirror, exclude. For now, we're not going to mirror, we're just going to insert the assembly. We're going to come down here, we're going to turn off these casters. We don't want to see those, so we can just exclude them. Or we can hold Control and select multiple ones at a time, and right-click and hit exclude. So we'll hit OK, and we'll insert then our assembly copy without the casters. Now if we wanted to move this, we can move our coordinate system. Let's change this to 0 and 100, and you see it updates with that coordinate system, so it's tied to it. The next thing we want to do is we want to go back and make a change to the original assembly. So we're going to open up the assembly here. We're going to make a change. We're going to add a part to it. We're going to make a copy of this blue base down here. So what I'm going to do is just drag steering wheel over. I'm going to hold down Control and click the arrow to make a copy, and we're going to move it up here to the top, and we'll add a copy of that. So now if we go back to our other assembly with the assembly copy, you can see it's now updated with that part we added to it. Alright, again, if we come back here, we can select this part, and let's say we want to replace it. We'll click OK. We can replace it with the green one this time. And let's say we also want to add a feature. So we'll do a cutout, and we'll create an assembly feature. I'm just going to create a simple cutout here. So there we have a cutout. So now if we switch back to our other assembly, you can see it hasn't updated, and we have a clock over here indicating that the assembly is out of date. So what you can do, you can go to Tools and go to Update All Links, or you can right-click and go to More and go to Update All. So if we do that, you can see now it's green with our cutout in it. There's the other option under More that I talked about in the slide. We have Freeze. And what this does is it freezes all the links between the parts. So if we freeze that right now, you can see there's a symbol up here for frozen. It's got another lock next to it, lock and the link symbol. So if we go back to the original and we make a change, let's say we want to replace these parts with the holes on them, and let's say we don't want holes in them, so we have some brackets here without holes, and then we'll replace those. So now if we come back to our assembly copy, you can see it hasn't updated. Even if we go to Tools and Update All Links, it won't update since we've frozen it. So to undo that, we can right-click, go to More, and go to Unfreeze. And now it'll unfreeze and it'll update to all the changes that we've made. So there's the new inner assembly copy. Let me close out of these. Alright, the next thing I want to talk about is the alternate position assembly drawing views. The alternate position drawing view is a drawing view derived from an alternate position assembly, and it displays multiple positions of the parts that move within that assembly. The primary position is the assembly in its entirety, but you can only have one primary position displayed in a drawing view. Alternate positions are subsets of the entire assembly, and you can have one or multiple alternate positions defined. And I'll show you how we do this going through the drawing view wizard. We can choose our assembly and our primary and alternate views. So I'll show you an example of that in a second. Some new thing with callouts, you can change the callout aspect ratio. You also have a few options with the border text control here. You can fit the width, or you can change the aspect ratio as well. And I'll show you how you can change the aspect ratio of text in a text box. For tables and parts lists, there's a couple options. You can create the table on the active sheet, which places it on the active sheet where you have your drawings. You have the option to change the page gap. So if the table wraps, you can choose the gap between the separate tables, and then you can also choose the placement of where you want it to be, or excuse me, it's already a predefined origin. With the new sheets, though, you can choose the position of it, your X and Y position. You can also choose to place it on new sheets. You can pick the size of the first sheet, as well as any additional sheets that the table might extend onto. And then you have the option to turn on and off the sheet backgrounds and maintain the sheets with the table size. So I'll show you all this in a minute as well. The number of header rows is something new. Prior to ST5, there was only one row for headers in a table. Now you can place any number of rows. You also have the option to merge with the next horizontal or vertical cell, so that you can make a header with multiple cells combined together, and add multiple headers if you'd like, and the number of rows. Some new improvements on aligning dimensions and annotations. You can align callouts with each other. You have the option to do horizontal top. So these are horizontal to each other, and this is aligned to the top of the one next to it. Horizontal bottom, they're horizontal, and this one's towards the bottom. You have vertical left, vertically aligned to the left, or vertically aligned to the right. We have kind of the same thing with breakpoints, and I'll show you this in a minute. We have the options here to align vertically or horizontally with breakpoints. And you can also line up dimensions. To do that, let's say we had this 20.54 dimension placed, and we're placing this 22.81. All we have to do is mouse over this other dimension, and they'll both highlight red, and you can click to place it, and they'll be in a line then. The dimensions are aligned, but they are not locked to each other. So if you want to come back and drag the dimension to another location and move it up and down, you can, and it won't bring the other one with it. So I'll show you that. It also works with angles. If you place a couple angular dimensions, they'll become concentric to each other. Another thing, we have nail boards, and there's a couple of new commands. Nail board creates a flattened view of the wire harness. You can add a drawing view of the connectors. If you want, you can insert bends to bend some of the wire harness. The connector table places a table using the harness information, and you can also create a conductor table. These commands will not work with your legacy wiring files created in ExpressRoute, however. And I'll show you an example of this in a minute. Other things with nail boards, you can add dimensions. So you can add dimensions right to the wires, and they are driven dimensions. Another new tool is Geometry Fix-Up. This is really useful. If you go in and do the geometry inspector on a model, you hit go, it'll tell you your faults. You can come in and select the faults you want and hit heal body faults, and it'll attempt to heal those faults for you and create a complete part. And so it does a really good job. So that's a good, useful tool. So let's go back to Solid Edge and we'll look at some drafts real quick. What I'm going to do is do the alternate position. So I open up an assembly that we have here. You can see when we open it, it comes up and asks us to select the member we want. We're going to pick closed right now. And if we come over to our alternate assemblies, you can see we have a couple different members we can choose from. So we want to pull these out into a draft file. So what we're going to do is I have one with a view created already. To create a new one, we can just go to our view wizard, hit OK on our assembly, and it comes up with the alternate positions. We can click an alternate view to add it. We'll hit next and place it at a right view. And we're just going to place it shaded with edges so it's easier to see. And so now we have our view there. Here's our primary, the shaded one, and then you can see our alternate. If we go to properties, you can see we have a new space up here for alternate positions where you can have the primary and the alternate, and you can change some settings with these. We're just going to turn off the hidden edge style with our primary and hit OK. Also, what you can do if you right click on the view, you can go to set primary and alternate positions, and you can change the positions if you'd like. We're just going to add 2 more to this view, 90 and 30 degrees. We'll hit OK and update our views. And there are some new alternate views then for you. Next thing we're going to look at is some of the auto balloon. So I have a quick look sheet here, and it has an ISO view of this assembly. If we go to our parts list and click on the assembly, normally what you can do is place the sheet here, or the list here, and you can move it to another sheet. But here I have options already saved out, so I'm just going to click that, and I'll show you what they do in a second. I'm going to click to place. And now one of the new things with auto balloon is it does a lot better job of placing the balloons. You notice the leader lines won't cross over each other, and it does a better job of just laying them out and a better view. If you notice down here at the bottom, it added a couple tabs for us, and here it moved our sheets to another page, 2 pages for us. So if we click on one of them and go to properties and go to general, you can see some options we have here. I have this saved down as new table, and you can choose the height if you want. You can choose to fill in the end of the table with blank rows like we have here. You can wrap table data. Also the location, we have the create new sheets for the table, and we have the options for the first and additional sheets, what we want them to be, as well as the locations. If we come to list control, you can see we have top level list. If we had atomic list, all parts displayed, you can see it's going to create 14 different tables for us. So you have that option to turn that on if you want, and we're just going to leave it as our top level. So that's some new things with the parts list and some tables. Now we're going to look at some aspect ratio. Here we have some text boxes. We can highlight our information here and go to properties, and what we can do is go to our indents and spacing, and down here in spacing we can change how we want it to be. Right now it's single spacing, you could change it to double. We're going to go to exactly, and we're just going to double this value and make it 10 and hit OK to add some more space between our sentences here. And now under bullets and numbering, you have all your bullets here, and under numbering we have Roman numerals now. We have uppercase and lowercase, so we're just going to select uppercase, and there we have some Roman numerals now. If we come over here to this other text box, we can make some changes. Let's say we want to change, this is the solid edge ISO font, we can highlight that. We can come here and pick solid edge ISO. We also have ANSI and a bunch of other styles, so we can just grab that sentence and change it quickly. Here, this is red, we can change it to red. This is green, quick and easy to change it to green. Aspect ratio, the new thing here, we can highlight this and change this aspect ratio under properties and go to paragraph. We have aspect ratio here. Let's say we just want to make this 0.71 and change our aspect ratio. So there, quick and easy to do. So there's some new stuff as well. All right, the next thing I'm going to show you now is nail boards. This is my last example. You have ANSI nail board draft. You also have ISO nail board draft. It comes in every style. I'm just going to do an ANSI one right now. Here you can see we have a 4x8 sheet of plywood. Under the diagram tab is where these are going to be located, our nail board options here. So we're just going to click nail board and pick the assembly that we want to place here. Here we have a wire harness on a part, so we're just going to hit open. and it's going to give you some options. Your main run you can select from your largest diameter wire. This comes from your wire harness, your largest conductor, or you can go in here and use user selected, and you can come in here and pick what wire you want to use. So we're just going to stick with largest diameter. You can give it a name. We're going to leave our height and width 4x8, the same sheet as our plywood. We're going to hit OK, and we're just going to kind of rough this in here and just place it. And there it places our wire harness for us. Now this one's sticking up here, so we're going to do insert bend, and you can insert a radius and the angle, and we're just going to leave it at 4 inches of 90 degrees and click somewhere on our wire here, and you can see you can place it left or right. We want it bend to the right, so just click to place. Again, we want to bend our main bundle down here, so we'll just click again, and then we want to place it up here, so we'll click to place, and there we inserted a couple bends, and you can just click and drag and move this around. So we'll bend this up a little bit so it's out of the way. We can move these other ones, and moving these doesn't affect the overall dimensions of them. It won't change their length. You can move them 360 degrees like this and place it any way you want, and it won't affect the length. Like I said before, you can also place dimensions, so we can come in here and add a couple smart dimensions if we want. We can add some angular dimensions even here. And then what I said is with the new dimension thing, you can highlight over it and it'll place it in a concentric circle with it. So we can place it over here. You can see it highlights red. We click the place and now they're concentric. And if we moved one of them, it'll just move it and then they're not locked together. All right, so the next thing we want to do is add our connectors. So we'll click connector, we'll click one of our wires. It'll come up with our wizard here. We're just going to hit next and do connector view and finish. And now the default is 1:1 size. We're just going to make that a little larger so we can see. And there's one of our connectors. We can do it again. For connector with 4 wires, we're going to make this larger. And one more connector down here. Next and finish. Change our size again. And there we have our connectors. Now we can do our connector tables. All we have to do is click on our connectors and place our tables. And we have our 3 connector tables now. With these we can zoom in. We can grab it. If we want to change the size of the columns, we can just do that by click and dragging. That's easy to do. We can also just move our dimensions around or our annotations. Now one of the other new options is with the alignment here. If we do our lineup text, let's say we want these 3 to be in a line again, we can do our lineup text and we can change our breakpoints to be in line vertically or horizontal. Let's say we want to do horizontal and we want them all in line with this one here. So if we click that one first, then we can click our next 2 callouts and they'll all be aligned by the breakpoint. So that helps with aligning everything. So now that we have our connector table in place, we want to do our conductor table. So to do this, all we have to do is click the command, click our wire harness, and then I created again a custom setting up here to place this on other sheets. So I can click that and click the place, and now it created 2 other sheets for us. So if we go to our other sheets, you can see all of our callouts here, our name, color, description, all of our lengths. If we go in and edit properties, you can see that I created this on new sheets, D-size sheets, where I want it to be located. Also to have it fill the end with blank rows. You can come in and edit all the columns, what you want them to be, and these will update if you change the values of the actual wire harness. All right, and then one more thing is we now have a Solid Edge mobile viewer. So it's an iPad app. You can view part files, sheet metal, or assembly files on it. All you have to do is go to the application button, go to Save As, and there's an option to save it for your iPad. It's a .sev file. You can sync this using iTunes, or you can email it to your iPad and view it. All right, that's all I had today. I want to thank you for your time. Replays of our lunch breaks can be seen on our website at allyplm.com. Please email us any questions or future topics you have. Once again, I appreciate your time. Thanks and have a great day.